How are you? My name is Anna Timbetz, and welcome back to my channel. We are going through these LeetCode problems, and we are on question number 72. And I did not realize I have sandwiched this problem in the middle of a bunch of other problems, and I did not actually write anything or do a submission for this. So we are going to be live coding this problem. I'm going to start my timer because we're going to read through this question 2 or 3 times. I have not read through it. So full disclosure, this might be a little bit of a longer video. But I've already seen the name of it, and I've done something similar like this before. So let's go ahead and jump into this. This solution, by the way, is going to be in Python. So you are given 2 strings, word 1 and word 2. Return the minimum number of operations required to convert word 1 to word 2. Okay. You have the following 3 operations permitted on a word: insert a character, delete a character, or replace a character. Okay. I like that word 1 is horse and word 2 is Ross. Output is 3. So horse, Rorse, Rose, Rose, Ross. Okay. Intention, execution is the second example. The output is 5. Intention, inention, inention, enention, extension. Oh my gosh. Okay. So we have to either, I guess I'm going to read this one more time. Must consist of lowercase English letters. Makes sense. So you're given 2 strings, word 1. Return the minimum number of operations required to convert word 1 to word 2. You have the following 3 operations. So you can only do 1 operation per thing. I thought we could just kind of bulk do it. I just want to show you guys I haven't submitted anything yet. So 2 strings, word 1 and word 2. I feel like I always say this, I think dynamic programming is going to be the best for this, to do a bottom-up approach. Given 2 strings, word 1 and word 2, return the minimum number of operations required to convert word 1 to word 2. I mean, makes sense, and that's just what I'm thinking I need to do here. But I feel like this is almost, we're sandwiching this by a bunch of matrix questions. So my initial thought is bottom-up DP, table. But before that, we have a matrix. So we have a row and a column, right? 2, I don't have yeah, I do. Hold on, guys. Let me grab this. So this is my thought, and this might be a terrible, terrible thought. I also just rolled over my toe. What a day. So we have a row and a column. And let's say like this. And we have M, and I should have put together my other, whatever it's called, camera. So I think creating something where we have this would be word, let's say word ol and word less. I think the best way I'm going to be able to do this is define the length of each of these words. So for this one, it would be 6, giving me 2 extra spaces. So this one would be 8. So the length of each column or row, actually I did that wrong, but you guys get the gist. M and N. like that. Yeah, that would make more sense. I don't know why I did it down there. I haven't had enough caffeine. I'm still like drinking my caffeine today, but I wanted to get through as many of these as I can because I did all these I did most of these while I was gone. So, okay. Let's take this and apply that to our code. So M and N, we need the length of word 1 and word 2. That's what those are going to define. Just right off the rip. Because then we'll be able to create a 2D DP table with those dimensions. So, what did I say? MN equals the length of word 1 and the length of word 2. Now, from here, we then can create the DP table. And the dimensions will be m plus 1 times n plus 1. So for this, we're going to say DP equals 0 times n plus 1 for in range m plus 1. Okay. Whoops. Then let's go ahead and initialize that first row and column for this. So for I in range m plus 1, we are then going to say the DP index 0 is equal to this. And then we're going to do the same for j in range n plus 1. DP 0 j then is equal to j. So from here, I think we should fill up the DP table with the bottom up. So I don't know. I want I and j to represent the minimum number of operations. So DP I and j. So we're converting the first index I characters of word 1 to the first j characters of word 2. That's what we have so far. But we need to consider the 3 possible operations. Insert, delete, and replace. Based on those characters of 2 words. Those 2 words. So, given 2 strings, word 1 and word 2, return the minimum number of operations to convert word 1 to word 2. Insert, delete, replace. Okay. So let's do a for I in range here. I think I'm going to do like a for if else or for if else. So for this, it'll be plus 1. And then for j, because we also need j in range, 1 and plus 1. If word I minus 1 is equal to word 2 j minus 1, then if they're the same, we don't have any operations that we need. So we could just say I j would then be equal to dp I minus 1 j minus 1. Else the dp of I and j need to be equal to the minimum of the dp I minus 1 j minus 1 right? And then dp I minus 1 j dp I and j minus 1. And then all we'll have to do is return the dp of m and n, where m and n are the lengths of word 1 and word 2. So we're figuring out here which operations we need. So I think this makes sense. So we initialize, we have the table, dp table, we've defined what is what. So this is for no operations. This is to figure out what operations to then use for the minimum amount, and then we just return that. Let's run it to see if we have a problem. Invalid syntax. If I could spell 4, that would probably help. If word 1. If word 1 is equal to word 2. Got it. Wrong answer. Horse, Ross. Output 0. Attention, execution. Output 0. Okay. So where am I? So if word... Let's see if those spaces make a difference. Nope, they didn't make a lick of difference. Let's increment this by 1. Okay, that's what worked. Because I was going to say it didn't increment, it just kept everything to 0, so it didn't do what it's supposed to do. So I just forgot a +1. Okay, so we ran that. Let's go ahead and submit it. So close. So close to 50% in the runtime, but 73%. So this is actually a pretty good solution, despite having a little bit of a hiccup there. I'm not too mad about it. Not too mad about it. So, yeah. Okay, so that took us about 13 minutes to do, start to finish. That was pretty good. I actually really like that solution. I was thinking maybe there's maybe 1 or 2 lines I could change here that would maybe optimize the runtime. But overall, I'm not complaining. So I will post this in my GitHub repo, and that will be in the video description down below. You guys are more than welcome to fork and clone. Make it better, make it worse, have some fun. We'll learn something new, and I will see you in the next video. Goodbye. Thank you so much for watching.